So third changes. Can we do another thing to shift an equilibrium toward direction that we would like? By the way, this AE means at equilibrium. It means the same. It is the same thing as double R. So this is a reaction which is at equilibrium. The temperature matters, so we must state the temperature. And this is a constant I'm going to show you, define you later on, which shows the relative ratio of concentration of products to reactants. We are going to discuss this. So for a moment, ignore the temperature and ignore Kc until I define it. But what I want to do, I want to change the pressure. Pay attention that this is nitrogen gas, hydrogen gas, which is reacting together to form ammonia. Why do we do this? Nitrogen is coming from air. Hydrogen is coming from electrolysis of water, reacting together to make ammonia. Ammonia is a general cleaning solution. Also, ammonia is used to make fertilizers, to provide nitrogen to plants. So in case A, reaction is gaseous, is under a fixed pressure. Suppose this is the pressure. Let's call it P1. We have mixed nitrogens. The blue one are nitrogens with gray molecules, which are hydrogens. They have reacted at a fixed temperature and fixed pressure of P1, and you see reaction is an equilibrium. Why? You see you have NH3. These are NH3. And you have unreacted nitrogen, and you have unreacted hydrogen. So equilibrium reaction, you have reactant and product, mixture of reactant and product. In this gaseous mixture, if I increase the temperature, I'm sorry, no change in temperature. If I increase the pressure from P1 to P2, and P2, suppose, is larger than P1, that means we are changing, sorry about the change, we are changing the pressure in this reaction mixture. Is change of pressure also a factor that we can shift an equilibrium, or is it not? Well, chemistry is experimental factor. I mean, experimental studies. What is comparing B and C showing you? Look, that's 1 ammonia, 2 ammonia, and 3 ammonia in the mixture. Let's say 3 moles of ammonia. This is before changing. So we had 1, 2, 3 moles of ammonia. We are changing the pressure, and this is the result. This is the result. So what does results show you? The result is telling you, look, 1, 2, 3, 4, 5. So you had 3 moles of ammonia, 3 moles of product. Now you have 5 moles of product. Can I say, this is NH3, and this is NH3. Can I say the reaction shift to increase amount of ammonia? So what is the effect of increasing the pressure here? The reaction is shift toward right, making more product, correct? It did not reverse, it went forward. So that means a chemical reaction, in this case, we are involving gases only. A chemical reaction involving at least one component of the gas is going to respond to changing the pressure. It's going to shift. Is it forward or reverse? Depend on the reaction. Let's check why this reaction shifts to right. Why does it make more ammonia? How does Le Chatelier's principle suggest that this reaction must shift to right to make more product? So I'm going to clean up the board so we can see better. What did we do here? We increased the pressure of reaction mixture by pushing piston down, by increasing the pressure. By applying more force to piston, the volume is reduced, the pressure has gone up. If we increase the pressure, what would equilibrium like to do, guys? Can you help me? Anybody? What would equilibrium try to do if I increase the pressure? Somebody, tell me, talk to me. If I increase the pressure, what is opposite of increasing pressure? Anybody? Talk to me.
Decreasing pressure.
Yes. Good job, Abigail. So equilibrium will try to yes, exactly. Equilibrium will try to decrease the pressure. So what do we know about pressure, guys? Is there a relationship with what is the definition of pressure? Pressure and collision and number of molecules. Let me ask you a question. Suppose you have 5 kids which are playing in a nursery and they are walking around and playing in a room full of toys. What happens if I increase number of kids to 50 kids in the same room? Is there a possibility of collision, accident, because it's crowded? So guys, these two, pressure and number of the molecules, are directly related. This means proportional. That means the higher the concentration, the larger number of molecules, more collision. And by the way, pressure is defined as result of collision of molecules with the wall of their container. So molecules are continuously colliding with the wall. Suppose inside the balloon, you have certain amount of the air molecules are continuously moving, colliding with each other and wall of their container. So they are exerting force against the wall of the balloon. That is what makes pressure. So can I say the more number of the molecules of gases inside the balloon, if we keep the volume fixed, the higher the pressure. That's why at some point, if you're placing more gas inside, the balloon is going to burst. Why? The pressure goes up. So guys, we said pressure is proportional with number of molecules. I'm going to use N for number of molecules. So if equilibrium is trying to lower the pressure of reaction mixture, it can only do by increasing number of the molecules which are moving around and colliding together. The same way you want to avoid accident, don't place 50 people inside one room, 50 people, kids playing and moving around and running inside the room. If you make number of the kids smaller in a room, less crowding, less possibility of accident. So equilibrium is wise enough, guys. There is wisdom in everything in the universe. And I think our wisdom is result of cumulative intelligence inside every cell inside every molecule that we are made of. So equilibrium says, I can decrease number of molecules in the mixture. They will have less collision, I will have less pressure. That's how I counteract with the change, which was increasing pressure. So I can reduce pressure by decreasing number of molecules. And you know, as we said, equilibrium can only shift to right or left. That's all equilibrium can do. There is no other options. Equilibrium wants to counteract the change by shifting. Is it going to shift toward right or left? So I'm going to let you answer this. Guys, how many moles of gases on the left-hand side? 3 plus 1, right? So we are going from 4 moles. And you know, moles is indicative of number of molecules. 4 moles on the left are converted to 2 moles on the right. Equilibrium is trying to decrease number of moles. Should it shift to the right or left? Should it shift toward the products or reactants? You make a prediction. Right or left? Which direction decreases number of molecules? That's what equilibrium is going to choose. Shift to direction where there is less number of molecules. Obviously, it's going to shift towards left, because by going to left, you are decreasing number of molecules. 4 molecules are bonding to make 2 molecules. So this equilibrium, and see the actual practical experimental result shows that 3 moles or 3 molecules, either one doesn't matter, is shifted to 5 moles. That means there is more product. Reaction is shifting to right to make more product, because going to right is decreasing total number of molecules from 4 to 2. So what are we saying? We're saying that, yes, if there is at least one gaseous phase in a reaction mixture, and you have an equilibrium, equilibrium could respond to change of pressure. What is the response? You study the equilibrium. You use these concepts to predict direction of shift. Any questions?
So even though the molar mass is constant, just the fact, just the fact that there are fewer molecules,
Yes.
just
Right.
decreases the possibility for collision.
Collision, yes.
Yeah.
Yes. Molar mass doesn't matter. Mass doesn't matter. It's only numbers of molecules which affect collision, and it's collision which affects the pressure. That's it.